everyone, welcome back to my channel. Today we are going to be discussing about Introduction to Physics, all you need to know. So let's get started with it. Let's start with a small physics video I made for you all. I hope you enjoyed the video. Now let us see what is science. The word science means to know. It is derived from the Latin word scire. The science attempts to know the unknown, and during this process great discoveries are made. Physical sciences deal with the study of inanimate objects in nature. Science attempts to find the cause of an event. This is called aim. To achieve this aim, various phenomena taking place in inanimate and living world are observed. The reason behind a given phenomenon is determined and its correctness is verified through different situations. Now let us come to what is physics. Physics is also a branch of science that deals with the properties of matter and energy. It deals with external behavior of matter. For instance, how does a matter behave when force is applied to it? It also deals with interaction between matter and energy. Physics explains the day-to-day phenomena happening around us. It explains why lightning occurs during rainy days, why we wear light-colored cotton clothes in summer and woolen clothes in winter. It also helps us to know the working of various electrical devices, such as incandescent bulb, fluorescent tubes, electric motors, and how X-rays can be used to detect a fracture in a bone. It explains how ventilation in a room is achieved. Now let us see what are the branches of physics. The map of physics can be broadly classified into three categories: classical physics, relativity, and quantum physics. Now let us start with classical physics, and a good person to start with will be Isaac Newton. His laws of motion describe how everything made of matter moves about. His laws of universal gravitation tied together the motion of planets in the sky, with the falling of objects on Earth into one elegant and general description. He also invented calculus, a supremely powerful mathematical tool which has been used to derive new physics. It is mainly a part of mathematics, but physics and maths are inseparable. Newton also made strides towards the field of optics, which is the physics of light and how it travels. Optics is closely related to waves, which is how energy can travel through disturbances of a medium. Light doesn't need a medium to travel through. It can travel through anywhere. This leads us to electromagnetism, generally electric fields and magnetic fields. A physicist called James Clerk Maxwell who discovered that these two aspects are the same thing and derived the wonderfully elegant rules of electromagnetism. Classical mechanics is related to Newton's law and covers the properties and motion of solid objects. Fluid mechanics is a description of flow of liquids and gases. It might be difficult because motion of tiny things can be complicated, which leads us to chaos theory. It is the description of large complex systems and how small differences in initial conditions can lead to very different outcomes. Thermodynamics is a description of energy and how it passes into one form to another. That's all of classical physics, and this is a picture of how physics looked like in the 1900s. Now, there were many questions which were left unanswered, and while finding the answers, new domains of relativity and quantum physics were invented. Now, let us come to relativity. Albert Einstein was a genius who developed the theories of special and general relativity. Special relativity predicts that the speed of light is constant for everyone observing. It states that the energy and matter are different aspects of the same thing through a famous formula E equal to mc square. General relativity states space and time are part of the same fabric of space-time, while relativity describes things which are very big. other physicists were busy working at the very small in the world of quantum physics. Now let us come to quantum physics. Atomic theory probed the nature of atom, and more detailed description of the atom were developed. Condensed matter physics described the quantum physics of many atoms together, and that is where many great technologies have come from. Nuclear physics describes how the nucleus of atom behaves and explains radiation. Particle physics goes even deeper to find the fundamental subatomic parts that everything is made up of. Quantum field theory captures all of quantum physics and combines it with special theory of relativity. And this is the best description of the universe we have. Here are some of the sources used in this presentation. And for a little bit of more knowledge, quantum field theory doesn't include gravity. So physicists don't know how to join together quantum physics and the general theory of relativity, leading to the giant chasm of ignorance. In the future, scientists hope to close this chasm and come up with a theory of all physics. We call it quantum gravity. And there are many attempts to do so, such as string theory or loop quantum gravity, etc. But quantum gravity isn't the only thing we don't understand. There are major puzzles of dark energy and dark matter, which only makes up 95% of the universe. And to our surprise, our physics is only the remaining 5%. Then we have a cloud, which floats over all of physics, which is philosophy. Many of you might make fun of philosophy, but it is those big philosophical questions that motivate a lot of physics. Thank you so much for watching this video. I hope you enjoyed it. Don't forget to like, share, subscribe and comment, and I'll see you next time. Stay tuned for more. Bye.